In this video, I'm going to demonstrate how to perform a paired samples t-test using the data analysis feature in Microsoft Excel. So in this scenario, here we see a study with 8 different participants that were evaluated twice each. And so we have what's called a pre-test measurement, and then at a later point in time, a subsequent measurement was obtained, and we see an array of scores that are matched to each individual participant. And so with the paired samples t-test, what we're doing is we're examining a statistical difference between the collection of pre-test scores and post-test scores. In other words, we're going to examine if the average pre-test score is statistically and significantly at the 0.05 level different from the post-test score. So to carry out this procedure, I'm going to go up to my menu and I'm going to click Data. And I'm going to go all the way to the right, and I'm looking for a feature called Data Analysis. If you don't have this available in Microsoft Excel, you'll have to go to the File Options and add in this package for statistical analysis. So assuming you've done that, I'm going to click Data Analysis, and this dialog box will open up with a number of options. I'm going to grab the cursor and scroll down until I find t-test paired 2 samples for means. That's the one that I want, and I hit OK. And now I input my variables. I'm going to skip these first set of boxes right for a second, and I'm going to look for a small box that I can check called labels, and this will allow me to carry forward how I labeled each variable, or in this case each column. So the first bar here for variable 1 range is where I'm going to put the array of cells that contain the pretest, and I'm just going to highlight and drag my cursor down until I highlight the entire box or the entire array of cells, and that's entered the variable 1 range. Now I do the same thing with variable 2. I make sure my cursor is in the box, and I come back to my spreadsheet and I highlight the array of cells. Note that I also highlighted the headings, and Microsoft Excel will not statistically examine the headings because I put those as labels. The default will be 0.05 unless I have a different alpha level I wish to choose, but I'm going to leave it at 0.05. The hypothesized mean difference box here that you see blank is what the researcher hypothesizes from a null hypothesis perspective, and the default is going to be a 0. So the null hypothesis will state that there is a difference of 0 between the two means, which is a standard way of conducting a null hypothesis. So I'm not going to put anything into this cell. I'm just going to leave it blank. If the researcher has any particular reason for putting in another number on what they hypothesize to be a difference between the two, they could do that here, but I'm just going to leave that blank. In terms of the output range, a common way to output is to ask Excel to create a new worksheet at the bottom. I'm going to demonstrate the output range here, where the statistical output will be put into the same worksheet. And so I have to specify where I want that placed. So I make the cursor active in the output range bar, and I'm going to go up to my spreadsheet and I'm just going to click this cell right here. So the output will start in this cell. And once I have that set, I come back to my data analysis box and I click OK. And what you see here is the output of a paired samples t-test. So I'm just going to widen out this column so I can read all of the titles here. So what we see is that Microsoft Excel will calculate the average for the pretest, all the pretest scores, the post-test. In the paired samples t-test option for Excel, it will compute a variance. Now if you want standard deviation, you either have to enter the Excel command or select the descriptive statistics under the data analysis feature, or you can do it rather quickly here, and I'm going to do it right here. I'm going to type in an equation. I'm going to type in equals SQRT for the square root. I'm going to shift 9. I'm going to click this value right here. The variance of the pretest is the standard deviation squared. So I want to take it in the opposite direction and take the square root. And I shift 0 to close the parenthesis. I hit enter, and we see that as a descriptive statistic we have a standard deviation of 6.1 units around the average. I want to do the same thing for the post-test, so in this case I can just grab the cell, pull it over, and it will automatically advance to the next column here, or the next cell, which is G5 with a standard deviation of 5.01. The output will calculate the number of observations, which is our sample size. It also calculates a correlation, and we see that both pairs are highly correlated. I'm going to skip this in this video for now. The hypothesized mean difference is defaulting to 0. We have a degree of freedom of 7. Now the t-statistic here, I'm just going to put this in red. The t-statistic is the test statistic generated from the actual data. I'm going to skip the one-tail because most often we perform a two-tail test. I'm going to put that in a different color here. Now with the two-tail test, what we see here is that the critical t-value, this is based upon the t-distribution with a degree of freedom of 7, is set at 2.36 or 2.37 if we round. Now our calculated t-statistic from the data is 3.42, which is greater than 2.3. So that would lead us to reject the null hypothesis, which stated that there would be a difference of 0. And the probability that we would be committing a type 1 error, in other words, the probability of rejecting this when it should not be rejected, we see is less than the standard 0.05. In this case, the exact, or the very closely estimated p-value is 0.0112 or 1.12%, which is less than 5%. So what we would conclude from this analysis is that there is a statistically significant difference in the means between the pretest and the post-test, and we would just go to the two average values up here. I'm just going to put that into a different color as well. And because the statistical outcome says that these two are significantly different, then we just say that there was a significant decrease in the scores from the pretest to the post-test. So this ends this video on using the data analysis feature in Microsoft Excel for a paired samples t-test.